Okay, so we come to the next talk before our break. Please welcome Nikita Stupin from Mail.ru. I've met Nikita last winter at the InsomniHack conference in Geneva, which is a partnering conference of Swiss Cyberstorm. So as conference organizers talk a lot about with each other, and they're more a hacker-oriented conference. But I thought Nikita was a very interesting speaker, and when we talked about a possible talk, he came up with a new research project. And I'm very happy he's here. Nikita is from Moscow. He works for Mail.ru, which is a huge soft mail provider. Can I say that?
Yeah, it's a mail provider, which like Google Gmail and so on, and also cloud services and gaming stuff and so on.
And
so
you're huge, aren't you?
Hmm?
Mail.ru is a huge company, isn't it?
Yeah, really huge. So.
Yeah, very well. So you're going to talk about access control vulnerabilities in GraphQL, new stuff, new research, new vulnerabilities for everybody. Have a good talk.
Thank you. So, as Christian already introduced me, I won't repeat that. So, let's start with the plan. First of all, we are going to talk about what is GraphQL in a nutshell, and how can we analyze it, what tools can we use. Then we will move to the attack surface, so what can we attack there? And then we will show and look at some examples of real-world vulnerabilities that I found on bug bounties while researching this topic. Then I'll propose some defense mechanisms that can be implemented for safe and convenient protection against access control vulnerabilities in GraphQL. But basically, who cares about GraphQL? Who does know what GraphQL is? And it turns out, despite this is a relatively new technology, it's like 4 or 5 years open sourced, there are a lot of companies that already adopted it, including big ones like Facebook, GitHub, Shopify, Twitter, and many, many more. But also, small companies are also adopting this. And what is a GraphQL? From a client-side perspective, from a perspective of a browser, or from perspective of a mobile phone, it's a way to fetch the data from a server or modify the data on a server. And it's not a database, so sometimes GraphQL compared with SQL, and it's kind of wrong. It's more right to compare it with REST APIs. And GraphQL solves main problems of the REST APIs. The first main problem of the REST API is data overfetching. It's when you want to get from API one single piece of data, for example, name, but in response you are getting the last name, the number of repositories, the type of the user, the ID, and so on. And this creates an extensive load on the network, so performance of the website goes down, and developers don't like it. And data underfetching, it's when you are want to get some different data and you have to go to different endpoints. From a first endpoint you get, for example, organization names. From the second endpoint you get repository descriptions, and from the third endpoint you get something else. And this again creates an overload and slows down site performance. So developers created a GraphQL, and it fetches exactly the data you need. On your left, you have an example of GraphQL Query, and as you see, we're requesting a user and its organizations and repositories. And in response, we're getting exactly this data, no more, no less. So now let's shift the gears and talk about how and where GraphQL, how GraphQL is exposed to the server. In a server, it's usually a layer between a client and a database. But it's in a perfect world. In the real world, behind the GraphQL, we usually have another REST API, we have like some microservice, some SQL database, and GraphQL here is like aggregates all of this into one API. We should keep this in mind when we're testing the GraphQL, because we should not test only the GraphQL itself, but also the technology that is behind this. For example, SQL, or if you're using NoSQL-based NoSQL. Now let's move to more practical concepts, and that is what is the basic types of requests in GraphQL. The first one is a query, and a query is just when you want to get data from a server. We've already watched on it. And how can we interact with GraphQL? I do this by using GraphQL, and it's similar to burp repeater. It's a tool like when you have request on the left and response on the right, and you can like do the history of your request and so on, and just have syntax highlighting, syntax formatting for helping you to write your requests. So GraphQL is very convenient for that. Since GraphQL uses HTTP as underlying technology, it can use any other technology, but in most of the times it uses HTTP. You can actually introspect this in burp. But in burp, it's represented as a string, a query represented as a string, so it's really inconvenient to like do a big queries when you have a lot of nested objects and so on. So I do not suggest that approach. I started with it, but I've moved to GraphQL. The second type of queries, of requests, called mutation. And you use mutation when you want to modify data, or you want to delete data on the server, or maybe create something. And it's almost the same as a query, with exceptions that you have parameters. And parameters, it's like when you want to change name, you specify the name, and so on. Here can be SQL injections. And the third type is subscription. It's more about when you want a persistent connection between a client and a server. For example, for a chat app, you want to, you have two options. First option, you can poll every time you want to get new messages, or other option is you are getting events when a new message comes in. So basically, the subscription is about getting an event, and it uses WebSocket as underlying technology. But the two main types are actually query and mutation. You will meet them in every API, subscription, not in every API. Here you can see what is called GraphQL Schema. And GraphQL Schema is a really important concept, and this concept helps us to understand what particular GraphQL API can do. So, in a nutshell, it's a huge JSON file. Like you can see, like 50,000 lines, and by itself you can't analyze it easily, because have you ever tried to read a JSON file with thousands of lines? I don't think so. However, we have a neat tool which I really like, and it's GraphQL Voyager. And GraphQL Voyager does something like this. He gets this huge schema, which we've got from API, and transforms it into some nice and pretty understandable graph. So you have your objects as the nodes, and you have connections as the edges, connections between objects. So as you can see, by default, GraphQL is introspectable. It means that anyone from the internet can do a special request, which is called introspection request, and receive all information about your API. What objects it have, what fields it have, what connections between them, and what you can modify or delete. This is not so scary as it might sound, but it really helps when you auditing a GraphQL API. And GraphQL Voyager gives you a nice overview over your API. Here is how you can use it. You are just copying the introspection query. It's not really different from ordinary query, but accesses some fields like kind and type. Then you are copying schema from response and copy-pasting that schema into the GraphQL Voyager. Then it builds a graph, and it might look like really complicated, but it's because it's a GitHub API. It's really big, but if you will like spend some time, you will understand it. But this is much more understandable than JSON. Like I found a couple of vulnerabilities using this, only these two, so I love it. And talking about vulnerabilities, what is the attack surface in a GraphQL? According to my experience of my bug hunter friends who are doing bug bounties, and publicly disclosed reports on HackerOne, the most big problem on the GraphQL APIs is access control vulnerabilities. There are also injections, but much less. I think it's because GraphQL is strongly typed. This means that, for example, if you have an ID parameter which accepts integer, you cannot specify the string into it, because GraphQL will check, before performing the query, it will check that the type of the parameter is the type of the argument you receive is actually int. And if it's not, it will throw an error. So strong type checks means more security by default. And most of access control vulnerabilities in GraphQL are relatively similar to the REST APIs. So the main difference is what tools you are using to find it, but there is also a small subset of these vulnerabilities which I call broken edges. And what does it mean? It means that, as you remember, we have nodes, it's your objects, and edges, which connects that object. But you also can add some data on the edges, and developers do that. And for some reason, they forgot to implement access control checks on the edges. And for one of these bugs, I've got $4,000 bounty, which is pretty nice. But I can't disclose this report because company I reported it to, do not like to disclose it. But there is similar report with a huge good bounty of 20,000, which is disclosed, but the same underlying problem is the same. So it's when developers added data to the edges, but forgot to implement access control checks on them. So I suggest you, if you are reviewing a GraphQL API, first look at the edges. And given that GraphQL API is a little bit more complex than a REST API, where can we implement an access control checks? So there are pretty much of options, and like on a front-end server, on a GraphQL, on a business logic layer, maybe if you're crazy on a database layer. But how do you think? Where is the best way to implement these checks? Actually, there is no correct answer. You can implement it on any of these layers, because GraphQL specification itself does not tell anything about where and how you should implement an authentication and authorization, so you can implement it anywhere. This, on the one hand, gives us flexibility, gives developers flexibility. On the other hand, this is more prone to errors because developers have a good imagination and can do many not secure things. However, according to my experience, there are two good ways, two convenient and safe ways to implement these checks. And this is using the resolvers or using the GraphQL directives. But what is a resolver anyway? Resolver is just ordinary function which actually fetches the data from when you're performing a GraphQL query. So for example, resolver for a field name may be a SQL request for a database. So you're just writing ordinary code. And of course, you can implement right there an access control checks. So before you're accessing some data, you're implementing access control checks. That's kind of easy. The other option is using directives. And directives is a part of GraphQL language. And there are no default directives, almost, but you can implement your own. And implementing directives and using them for access control checks gives you more granular access control, so you can specify that this user can access not the whole object, but he can access one specific field or two specific fields, for example. It's kind of problematic with resolvers. And also, since directives is like native for GraphQL, it gives us more clean code and more clean APIs, and more clean API code we have, the less likely we will have vulnerabilities in it and mistakes. So we're coming to the end. Here is the useful links if you want to dive deeper in the GraphQL or maybe some other aspects of it. So to learn it, links to GraphQL, GraphQL Voyager, these neat tools. And if you want to develop GraphQL, you can go to the last link, which contains the code examples of how to implement access control checks using resolvers and directives. And that's it. Thank you for your attention. If you have any questions, I'm happy to answer them right now. Or you can later email me, write on Telegram or maybe Twitter, and we discuss it more privately. Thank you.
What do we have as questions? Not so many. I'll kick it off. More broadly, how do you see the role of GraphQL in web development and future development? Is this really the new way to do it? Will this complement REST APIs, or how is it going to look? Meaning, will this go away in 2 years, or should we really solve this problem now?
It's now for most companies which have a REST API, GraphQL is complementary for them.
Okay.
So we have both. But while they have both, they're slowly deprecating the REST API.
Okay.
So so we're moving to the GraphQL slowly. And the new companies sometimes do not ever have a REST API. They have only a GraphQL API.
So that's a new focus, but there will be a longer transition, you think?
But I don't think that REST will die, because in some cases it's a little bit simpler to implement and to use. So sometimes REST is better.
Okay, good message. What other questions do we have? Thank you for the light. Not so many. I think you have your plane leaving pretty sure, so be happy to run off.
Yep.
Very well. Thank you so much for coming.
Thank
Some chocolate for you. Have a good trip. Thank you, Nikita.